Assalamu alaikum. Iba, how are you doing today?
Walaikum salam. Isaac, I am doing well. How are you doing?
I'm also fine. Today we will discuss about two problem set. Uh, First one, I will solve this, and I hope I will make you understand this problem. And I think you will also cooperate with me. So, I'm firstly I'm reading this question. Checking properties of the Cobb-Douglas utility function. Consider the utility function u of x, capital pi, xi to the power ai. So, here this is the Cobb-Douglas utility function where we have to check the properties of this utility function. Basically, the uh, properties of the utility functions are like additivity, homogeneity of degree k, and homotheticity. And now we will check for this specific utility function. Here, first, we note that this utility function is just a generalization of the Cobb-Douglas utility function to n goods. Here we can see that uh, I is equal to 1 to n. So, firstly, we will see that when n is equal to 2, how the utility function stands. So, here, let n is equal to 2 goods, x1 and x2. Then we will get that the utility function u of x is equal to capital pi xi to the power ai is equal to x1 to the power a1 into x2 to the power a2. And this capital pi basically represents the product of the sequence. So here, that's why we multiply x1 to the power a1 and x2 to the power a2. If there are n goods, then we will multiply from x1 to the power a1 to xn to the power an. So here, a2, a1 and a2 is greater than 0. To check the additivity property of the Cobb-Douglas utility function, at first, we have to know what is additivity of utility function. Additivity means, suppose one consumer, he consumes apples and he also use smartphone. Apples mean fruits, not iPhone. Uh, so he consume apples. So if the marginal utility from consuming apple uh, has no impact on using his smartphone, then we can say the utility function will be additive. And like this, if the marginal utility of using smartphone hasn't uh, has no impact on consumption of apple, then we can say the utility function is additive. So, additive when a function utility function becomes additive, we can add the marginal utility of the goods, and the total will be equal to the total utility of this consumer. So here, if we want to see the Cobb-Douglas utility function maintains additivity or not, we have to first do the marginal utility of additional amounts of good k. So here we make the marginal utility of product k. We will see the mathematical manipulation here. So if we take x1 and x2 commodity, we will first calculate the marginal utility of good 1. And marginal utility of good 1 is a1 divided by x1 into x1 to the power a1 into x2 to the power a2. And if we substitute k with 1, then we will get ak divided by xk into capital pi xi to the power ai. And we get this capital pi from here. For marginal utility of good 1, we can see that a1 divided by x1 is multiplied by x1 to the power a1 into x2 to the power a2. And this is basically the utility function for 2 goods. But if we want to take n goods, then this capital pi will stand there. Now, like this, we get the marginal productivity of good k. And now we will see that if the marginal productivity of good k doesn't depend on the amount of another good, then we can say the utility function is additive. To make this sure, we have differentiated a marginal utility of k with respect to xj. That means another good. So if this different derivative not is equal to 0, that means the marginal productivity of good k depends on another good xj. So this function will not be additive. And if when marginal productivity of good x doesn't depend on another good xj, then it will equal to 0. And we can say the utility function can be additive. So we see this with respect to k. Now, if we want to see this with respect to 1 and with respect to good 2, then we can be more clear. So here, marginal utility of good 1 is presented here. And I have recently cleared it here. So you can view this. And we get a1 divided by x1 into x1 to the power a1, x2 to the power a2. Here we can see that marginal productivity of good x1 depends on x2. Here we can find x2. So we can say that marginal productivity of good 1 depends on good 2. So the function won't be additive. And vice versa, if we calculate marginal productivity of good 2, we will see this, that marginal productivity of good 2 depends on x1. So this utility function breaks the additivity rule. And now I will move to the homogeneity part. And we know that to check this, if a utility function is homogeneous or not, firstly, we have to multiply the function with a common factor. Here we use the common factor as theta. So utility function is multiplied by theta. So utility function of theta x, and then we can see that capital pi, which represents the product of the sequence, then theta xi to the power ai. And by mathematical manipulation, we get that theta to the power summation of ai. And how we can get this ai? And here we can see theta to the power ai. That means there will be theta to the power a1, theta to the power a2, theta to the power a3, tends to theta to the power an. And we know that if base is the equal, then the power will be summed up. So here the power a1 plus a1 plus a2 is summed up, and here we present this by summation of ai. And here we get the main utility function. So by this, theta to the power summation of ai into ux. So by this we get that in the next slide, we get that uh, theta to the power summation of ai is the degree of homogeneity here. And we for two goods, we can see that summation of ai means a1 plus a2. And when a1 plus a2 greater than 0, that means a common increase in the amount of all goods produces a more than proportional increase. But when a1 plus a2 is less than 1, this is called less than proportional. And when a1 plus a2 is equal to 1, then a common increase theta. That means the consumption of all goods generates a proportional increase. So here summation of ai can be greater than 1, less than 1, or equal to the 1. Okay. So we can see that this utility function is homogeneous. Now I am moving to the homotheticity. To check this is a utility function is homothetic or not, at first we have to uh, manipulate the utility function to a monotonic transformed function. Here we made the monotonic transformation of our given utility function u of x, and the homothetic function is v of x, which is g of u of x. So here we can see that marginal rate of substitution of L for K is equal to minus AK divided by AL into XL divided by XK. I have showed the mathematical manipulation in the next slide. Here we can see uh, a function is homothetic when the marginal rate of substitution, the marginal rate of substitution of L for K doesn't depend on another third good. Here we take H as a third group or a third party group good. Here, when marginal rate of substitution of L for K doesn't depend on good xh, then it will be 0. That means the marginal rate of substitution of L for K will be independent uh, of good H. Then the function will be homothetic. But if the marginal rate of substitution of L for K depends on the third good xh, then this utility function won't be homothetic. So there is a printing mistake here. It will be is equal to 0 to become homothetic. So now we can see that marginal rate of substitution of L for K doesn't depend on any third good. We can't see any hx here. So we must say this utility function u of x is homothetic. And graphically, we can also show something in the next slide. In the next slide, I have showed how I calculate the marginal rate of substitution of L and K. I think you will understand once if you see this. And now I am going to describe an additional note on homothetic preference. Here, this note says that when preferences are homothetic, the marginal rate of substitution between the two goods is just a function of the consumption ratio between the goods, x1 divided by x2, but it doesn't depend on the absolute amounts consumed. If we double the amount of both goods, the marginal rate of substitution will be equal. So if we want to check this, and if we multiply x1 with a and x2 with a by the same amount a, and then the ratio will be a into x1 divided by a into x2. That means a will be cancelled out. And we will get the ratio x1 divided by x2 uh, equal to the previous one. By graphical representation, we can see that if we manipulate y by ay and x by ax, the slope in this point will be equal. That means the ratio of xy will be equal. The slope will be remained same. For this utility function, we can say that this given utility function isn't additive, but it is homogeneous of degree theta to the power summation of ai, and it is not, and it is absolutely homothetic because marginal rate of substitution of L for K doesn't depend on any third good. That's how I feel I can make you understand this. If you have any question, please you can ask me, and if there any suggestion to me, you can give.
Mm. Thank you so much, Ishak. I have a question. Uh, you mentioned the monotonic transformation. I do not understand the term and how do you do that monotonic transformation?
Monotonic transformation means here we have shown the main utility function. Main utility function is x1 to the power a1 into x2 to the power a2, or when we take n numbers of goods, that is capital pi xi to the power ai. Monotonic transformation means we will just manipulate this utility function. We can add some a constant, or we can subtract some constant from it, and we can just simply make it monotonic transformed by adding or subtracting, or just some mathematical manipulation.
Thank you so
Can
much,
you
Ishak.
understand me?
I understand this monotonic transformation. I have another question on the first part of your answer.
In additivity.
Yeah, additivity. There was
Okay.
the equation. Uh, no, not equal zero. There was the equation like equal to zero, not equal to zero.
Okay, I am moving to this slide.
Below this,
Is
page.
it
Yeah. Uh, Depends on the amount of other goods consumed. I don't understand these things. You differentiate utility of one good to the another good, and you show that if it is not equal zero, then it is dependent. And I don't understand the things.
okay? I will try my best. Um, the basic part of additivity is that the marginal productivity of one good doesn't depend on another good to be additive. So here marginal productivity of good K is UKX. And if we make derivation of this with respect to xj, and if we get is equal to 0, that means the marginal productivity of good K doesn't depend on good xj. But when it is not is equal to 0, that means
Yeah.
the marginal productivity of good K must depends on good xj. But when marginal productivity of one goods, when marginal productivity of one good depends on another good, then the additivity is cancelled out.
Will be zero.
Can I understand you?
Yeah, I understand these things. Uh, And what does mean this capital pi
Capital
in the
pi
function?
means the product of a sequence. Here we can see the sequence as like x1 to the power a1. And when I
Is
is
this a
equal to 2,
multiplication sequence?
yes, it presents the multiplication. Product means the multiplication of the sequence.
Thank you so much. I understand all the things you uh, try to explain. Uh, Thank you so much, Ishwar,
You are
for your
most
nice
welcome.
presentation.
And there is another problem set for you. Hope you will make me understand this problem. And I'm waiting eagerly for your discussion.
Sure,
Thank you
sure,
very
Ishwar.
much.
I will describe my part then.